So the next step, which is so that's the first step, the physiographic features. The next step is going to take a little bit more work. That's soil features. So to do that, we need to dig a soil pit. And I'm going to just make a relatively small soil pit. I'm going to try to make it at least 30 centimeters by 30 centimeters. I'm going to try to get at least 30 centimeters deep. I might go a little bit deeper than that. I'd like to get at least, for a true soil pit, I'd like to get down to the C horizon, down to the parent material. For our purposes here, I just want to try to get well into the B horizon. So I'm going to go ahead and dig that soil pit now. And if you haven't seen the other video where I talk about digging a soil pit, just two important things, especially when we're digging soil pits in areas that we use for teaching so we don't cause too much disturbance. I usually try to lift the forest floor off intact and set it aside. And then when I dig the soil pit, I try to pile all of the soil in as small of a spot as possible. And then I make sure when I'm working on the soil pit, I don't step on that. I don't grind it in. So hopefully at the end, I'll be able to get most of that soil back in the pit and then cover it up with the forest floor. It'll still probably not look perfect, but I'm trying to leave as little impact as possible. Okay, and in this case, my forest floor, sometimes you get a soil pit where the forest floor is very densely matted and full of fine roots, and it holds together very clearly. This one is very loose, so I don't think I'm going to be able to get this forest floor to hold together very well. So, as you can see, it's pretty thin and not holding together at all. So I don't think in this case I'm going to be able to preserve that forest floor layer. So I'm just going to dig out the soil pit and try to pile the soil in as small a spot as I can. Okay, let's take a closer look at the soil pit. I've got the camera set up on the soil pit right now. Filming a small soil pit is pretty challenging, so I hope it looks okay on your end. Just to give you a little bit of context here, I have a tape measure here. Ideally, I'd have a soil-specific tape measure that I could put the 0 right at the boundary between the organic soil and the mineral soil, and then it would increase as I go down. I'm just using an Eslon tape because I don't have a soils tape measure with me. So just note, kind of ignore the numbers here, just use them for scale. So this number 30 is right about where I think the boundary between the organic and mineral soils is, and then this is about 10 centimeters, and if you can see that, that's about another 10 centimeters. So that should give you some context. I know you lose the 3 dimensions in the video, so right here I'm just dragging across the top of the forest floor, and it's been disturbed a little bit, so this isn't the intact forest floor. We're mostly looking at the F horizon here. So yeah, you can see this F horizon. It's very loose and partially decomposed, but I can still see some fibers and some materials in there. Another interesting thing, do you see that right there? That's a little piece of charcoal. There was another one over here too, which were probably from some roots that burned underground, or maybe it was just a piece of charcoal that got buried. Sometimes you'll find kind of a little charcoal tunnel that will be from a root that had burned in a previous fire. So let's focus on the mineral soils here, and I think this is kind of the boundary. You notice we've got this layer here that's pretty dark in color. So there's 2 possibilities here. One is that this is the H layer, that this is still part of the organic soil, and it's part of it's the humus. So I'm going to take a little bit in my fingers here, and there's definitely organic matter in there, but I'm also feeling some grit. I'm feeling some mineral particles in there. So I'm gonna, and this can be pretty arbitrary, but I'm gonna say that I think we've got 30% mineral particles in here. So this dark layer is an AH horizon. So on your sheet, under A horizon there, you see there's a checkbox for AH, And let's try to get an estimate of the thickness for this. It varies a little bit, but if we look at it right here, here's 30 centimeters, it's 25. I'd guess this is probably about, maybe about 4 centimeters. It's a little bit thicker over on here, a little bit thinner over here. And when you're looking at a soil, you can always kind of try to scrape a little bit to freshen it up and get a real clear idea of where those boundaries are. So here, over here, it's maybe 4 centimeters. So let's call it a 4 centimeter AH horizon. And it's H for the humus in here. This dark color is coming from humus. But it's a mineral horizon. You can even see those specks of minerals, or you might be able to see those light colored specks here. Now this might be a bit challenging to see from where you are, but when I look down here, it's a little tricky. This spot here actually looks a little bit darker red, but on the whole, this stretch here looks a little bit paler in color to me than the soil below it. I have the camera set up on this side, but on the other side, it's even more, stands out even a little bit more. We've got this kind of light, ashy colored soil underneath here. Here's some from the other side. It's a little bit more pronounced, but I can only set up the camera at one side. That's one nice thing about digging a soil pit, is you can kind of look around the soil pit. So that may not be totally in focus for you, but just note how this is kind of a whitish, ashy gray. And that's because that's an AE horizon for eluviation. Sometimes students see that and they think it's ash from a fire. Usually we don't see, if we see signs from a fire, we actually see charred black material. We don't usually see that, a light colored ash from a fire. But that is where the name, I think the name podzolization comes from ash. It's kind of an ashy looking layer. So I'm getting ahead of myself. That AE horizon, the E stands for eluviation. Eluviation is when silicates, iron compounds, aluminum compounds, and humic compounds get leached out through the soil. They get washed from this horizon down into the horizons below. So it's a little bit tough, and sometimes when you see one of these, it's really striking. It's extremely almost white in color, and it can be very narrow. This one to me looks like it's a bit wider. It's a little bit harder to see where that boundary is on this side. I would say maybe that boundary is going to be somewhere around here. It's a little bit of a gradation. Sometimes it's a real crisp boundary. Here it isn't so much. And like I said, on the other side of this soil pit, that color is really pronounced. So I'm pretty sure we can see that this is an AE horizon. So let's try to measure that a little bit. I think I'm going to give that maybe about 5 centimeters in depth. So I'm not a soil scientist. I'm not being super precise here. And if somebody who's a soil scientist corrects me, I would be happy for that. But so let's say we've got an AE horizon. That's about 5 centimeters in depth. And then below that, we've got, I haven't dug this pit down too deep. I've dug this pit maybe about 40 centimeters deep. Below that, we have our B horizon. And let me get a little scoop of this soil, because the part that you're looking at is very rooty. You can see it's definitely darker than that AE horizon, and it's a little bit rusty red in color. So this to me looks like a BF horizon. The F for ferric, meaning iron. So when those particles, especially those iron particles, get leached out of the AE horizon, they accumulate in that BF horizon. So those iron oxides, those aluminum oxides, are what give the BF its name. And as Dr. Samard said in one of the other videos you might recall, there's potentially a couple of different kinds of BFs. We can have a BHF or a BFH if we also see a lot of humus mixed in there. In this case, it's not very dark in color. I don't see a lot of humus mixed in there, so I think this is a pretty clearly just a regular BF horizon. And I haven't, since I'm trying not to disturb the soil too much here, since this is just for this video, I haven't dug down super deep, so I'm not quite sure how deep this BF horizon is. I know that it's at least 20 centimeters if I look down to where I dug at the bottom of the pit, which is a little bit out of your view. Here, let me scoop just a little bit to get down to the lowest point that I was. So it stays pretty steady, pretty rusty brown in color. So if I go down to the bottom there, I've got probably about 30 centimeters of BF. So we could say that our BF horizon is at least 30 centimeters deep. So let's look at our sheet here and start filling this out again. And I'll come back and do the texture. But soil depth, we don't know for sure because I didn't really dig the soil all the way down. I know that we've got at least 40 or 45 centimeters. So we're at least probably in the shallow end. So not an extremely shallow soil, not a very shallow soil, probably in the shallow or deep. We don't know for sure, but that's one of those two. For coarse fragment content, here's some of the soil that I've dug out of the pit. There are some coarse fragments in there, but there's relatively few, and I compare this to the soil pit video that I did earlier that hopefully you've already seen in Malcolm Knapp Research Forest. There's relatively few coarse fragments in this soil. I think that's going to make it a little bit easier to texture. So remember, coarse fragments are mineral particles that are greater than 2, or rocks that are greater than 2 millimeters in diameter. So I'm going to say less than 10% coarse fragments here. It's possible it's a little bit over 10%, but that's my best estimate. And for soil color, I don't have a color chart with me, but this is definitely not a dark soil. This is going to be a medium or light soil. And for floodplain, we're definitely not in a floodplain here. Glaying is when we get these very light gray particles in the soil so normally this soil is very red, and that's because the iron particles, or the iron molecules, have oxidized. Sometimes iron compounds will have been formed in an absence of oxygen and reduction, and so we'll get very light colored, almost white particles in there. So we don't see any glaying, so no evidence of that. I haven't hit a water table, and no specific landform, and we haven't gotten to the bedrock, so I don't know what the bedrock geology is. So most of those things we're just going to leave blank for now. All right, let's texture some of this soil. I'm going to get some soil from the B horizon here. I'm going to pick out, remember the first step is to pick out the coarse fragments. Ideally, if you're doing this in the lab, you'd use a sieve that would let everything smaller than 2 millimeters pass through and would catch everything that was greater than 2 millimeters. So I do not have one in the field though with me, so I'm going to do it by hand. Fortunately, this soil has far fewer coarse fragments than some of the other soil that I've shown you. There's very, very few coarse fragments in here, so this isn't too bad. I'll just take a minute to get them out though. So the soil's not strongly structured. I don't see much structure to it. It's pretty fluffy and loose. All right, so I'm going to put a little bit of, so I guess first off, the first question, greater than 50% sand, grainy to very grainy, or less than 50% sand, non-grainy to slightly grainy. I always have trouble with this one. There's definitely a fair amount of sand in here. There are some finer particles mixed in with it though too, but I think I'm probably, oh, but I found a little millipede in here. That's one of those organisms that can break down that F horizon. I think this is greater than 50% sand just by looking at it and by feeling it. It's pretty gritty. So let's say greater than 50% sand, grainy to very grainy. And then let's do the moist cast test. I'm going to add some water. And that water actually just kind of ran right off of this soil. The soil's pretty dry at the moment. See if I can get it to absorb without washing everything away. Hopefully I didn't wash away all the fines. Here's my cast. Let's see. It forms a cast. It breaks apart pretty easily though. So I wouldn't say quite forms no cast. I'd say a very weak cast. So it forms a cast, but I can't pick up that cast. So that puts me in the loamy sand area. So it says non to slightly gritty, non to slightly sticky, worm, none. I'm not even going to bother trying to roll out a worm with this because I know it's not going to happen. So I think that makes sense to me. A loamy sand. There's definitely a lot of sand in this soil. There were some fine particles though that felt like loam, so it's not strictly a sand. So a loamy sand makes a lot of sense. It's possible if maybe we could call it a sandy loam if it formed if we were able to kind of very carefully handle that cast. And it's possible, yeah, maybe. So not being a soil scientist, I'm going to put this in probably the loamy sand, maybe a sandy loam somewhere in there. So if we go back to our data sheet, for soil texture, we have to, now I guess we have to decide between sandy or loamy. So I said that it's probably a loamy sand, which would put us in sandy, or a sandy loam, which would put us in loamy. I'm going to lean a little bit closer to loamy sand for this one. So for soil texture, let's call this sandy.